In Learning ZIG, Session 7 will cover structs, type inference, type casting, and modules. ZIG doesn't have C++ style classes, interfaces, or class inheritance. ZIG is more like C in this design choice and provides structs as simple medium to convey complex data collections and associated functions. ZIG structs normally follow naming convention to have init and dinit methods to act as object constructor and destructor. As in the example here shows, username struct being defined. A struct block with identifiers followed with colon and data type for it and to have a comma at the end. Then also a public function init so it can be called directly on struct identifier. We also see it returns user instead of self keyword as a better practice. Even in the printName function, the type of self-identifier parameter is user. While creating a new instance of user as inside init function, the internal fields shall be mentioned with .identifier equal to symbol. It does require all fields to be assigned with a valid value. Now let's run the ZIG code and see our output. Let's modify the printName function for more struct fields. Just to restate, every struct method defined with pub is publicly callable on instance of struct. ZIG supports anonymous struct literals. It's like the second parameter passed to print statements. We replace the struct name with dot characters and fill it in with fields. The anonymous struct could be coerced to other struct types if these get passed as function parameter or get returned by a function with specific return signature. Anonymous structs without field names could be treated as tuples in other languages. These can be completely anonymous if, say, passed to for any type field. Let's do a quick code sample for this. We'll add a new function anonstruct and pass it an arg of any type like in our example from ZIG guide. Let's call it hasLength. Actually, let's just print length if the struct has any field. Now passing it anonymous struct. Let's do a ZIG run and check. Struct declarations are always constant as types in ZIG must be constant or comtime, so cannot declare a struct with var keyword. Traditionally, in most languages, a function defined over a class or struct has self-argument to refer to the object on which it is called. If the access to data is not required within the method, then probably the method itself could be independent instead of being available on the struct. Some struct methods would just need access to fields value and not alter them, like our printName method in user struct. In such cases, struct objects can be created as constants. When the object gets changed in structs method, the self-argument must be annotated as a pointer of the struct identifier. As we have twice altering vector3 struct object in example, let's add change email method in user struct to update email on the object. Argument is self of type pointer to user object and the new email. Let's add a new user init with variable form. Update print method to print email as well. Call change email on it and print the details again. ZIG run shows the intended changes work fine. Here the altering within printName is not possible because by default the passed parameters in ZIG are immutable, irrespective of the object being constant or variable before being passed. Now let's gather some more details on type inference. Similar to C, ZIG is a strongly typed language, but similar to modern languages, it allows type inference in certain cases. Dot character before struct literal or enum value enables code to let compiler infer the type of value, similar to auto keyword in C++. Let's write some code to get a fell for it. Similar to tuple test block from ZIG guide, we'll create an anonymous struct with few different types of values. Let's use expect, as in std testing expect, to check for the correct values. Now let's run the ZIG code and see our output. Similar behavior can also be noted in switch statements. As we see in standard libraries atomic ZIG modules fence function, atomic order type argument gets passed, and we have a switch statement here which matches it with statements beginning with dot characters. So ZIG knows to infer the values following dot characters as data members of type atomic order and is able to infer them for match. Moving on to topic of type casting, that is an object of certain type converted into an object of another type. ZIG provides a built-in function as to cast an object into other type. This only performs casting if that is unambiguous and safe. It takes two arguments, first the target type and second the source object. But casting like integer to float values are not completely unambiguous. So ZIG provides other specific built-in functions for such purposes like float from int or int from float. Pointers need a special handling, so ZIG provides ptrcast. Argument is pointer to a object and target data type is determined by type annotation of where results are assigned to. As for the bytes and U32PTR identifiers in this example, every .zig file written in a project is internally stored as a struct object. When a module like standard lib is imported and accessed, ZIG is actually accessing data members of struct stored for standard lib object. Well-written library modules have a top-level public init method if required. Idea being all top-level function to behave as if they are available on that struct. This is it for this session.